when did you finish this project, Mauricio?
This project last year, I think, before the summer,
Yeah.
maybe, if I remember well.
Because I remember, I know that it's a pretty fresh project, like not too old, and it's very, very interesting in terms of production and fabrication, etc. So yeah, I'm looking forward for it.
Yeah. No, it's not so old, but we didn't get the prize, the first prize for it, because it was from a competition, international competition, and maybe we can talk about it later. But it was a great chance for us to experiment with this topic. So it's not so important to win competitions, because most of the time you do it for experiment something, because it's not easy to get clients that want that maybe want this kind of solution. So you can do it doing research or doing competition, I think.
Exactly. So I totally agree with you that competitions is the best opportunity for somebody that is starting his career as an architect to start explore different things that clients will never pay until they see it somewhere else. So if you manage to go viral, that's the best prize you can go from a competition. It's not the prize money; it's to manage to have shares in different kinds of sites and social media, etc., and start having your advertisement. This is how I met I learned about you and your practice through this one, and then it was Venice Biennale, and I said like, okay, these guys are great.
Yeah, because also exhibitions maybe are another great chance to experiment, to showcase something different, because you don't have all the limitations, all the restrictions you have in the real projects, so yes. Maybe you can do something a bit more experimental. I think.
Okay, before we start, I would like to introduce Justina and Darcy and Dalia, that are our tutors in the class. I'm not sure if Paula is in the cohort somewhere. She might be, I cannot see her on my screen. I think I should start by acknowledging that I dwell on and speak from a country that doesn't belong to me and has been under the care of custodianship of Awabakal people and Waribi people. So I pay my respects to elders past, present, and emerging. Before we start, I would like to introduce to our panel, our cohort, Mauricio and Angelo, that will join us shortly. Angelo is in a very exciting moment of his life, signing a contract, so he will be with us in a while. But Dr. Mauricio is an architect, postdoctoral researcher, and knowledge transfer manager at Politecnico di Bari, and he teaches digital and design fabrication. His research and professional activity concerns in the areas of architectural design and architectural didactics, also digital design and digital fabrication. He specializes in the field of stereoatomic architecture, and he's a co-author of several big prototypes and projects. Also, he has scientific contributions in many papers. He has exhibited in international fairs like Biennale di Venezia and Salon di Mobile, that I think that they're the two of the most important architectural exhibitions around the world. And also he has lectured in several universities. He recently published a book that is called Architectura 4.0. Mauricio, I'm waiting for my English version of it and not the Italian one, because my Italian are like the worst. So he's a co-founder of Barberio Coelho Architecture and New Fundamentals of Research Group. Dr. Angelo, that will come shortly, he's an architect and a professor of architecture and industrial design, School of Architecture and Design of Universidad de Camerino. and he has been a visiting researcher in IAC in Barcelona. In 2013, he was awarded with a master's degree from housing from Universitat de Roma, and his research and professional activity concerns in the areas of architectural technology, environmental design, and which focus on relationship between computational design, materials, and digital fabrication strategies. He has been published in post-industrial robotics, and also he has been awarded to the Italian National Scientific Qualification to become an associate professor. So without further ado, I'm going to leave the floor to Mauricio and looking forward to learn from what he has to offer.
Thank you very much. Hello everyone. Thank you, Tanya, for a great presentation. So few words. It's not necessary to add other words about me. Thank you, Tanya and Nicolas, for inviting me today. I'm very happy to share this my work and my knowledge about stereoatomic design, which was the topic of my PhD research. And I'm very happy to share it with Angelo, that will come later, because we started to work together on some projects and some research to implement some environmental design aspects in this field of study, which is relatively new approach, because stereotomy is historically linked to shell structure. So probably the most related fields are in engineering, shell design, structural analysis, and also architectural geometry. So we are also interested in environmental aspects. So we will talk about it a bit later in the end of the presentation. And I'd like to start my presentation talking about the place where I come from, because I was born in a region called Puglia in the south of Italy that is characterized by the millenarian use of stone for building architecture. This is the Baris Basilica, the Basilica of my city, which is the best example of a Puglian Romanesque architecture from the Middle Age. So to me and for the people coming from certain regions of Italy, like Sicily, like Puglia, it's common to talk about stone, to talk about vault structures, you know. And I've started this presentation this way because I believe we should design in different way depending on where the building is located. So I know it's not always possible. It's not always possible in modern times, but I think it's important to study the characteristics and the materials of local architecture prior to starting designing, in order to preserve and evolve the history of local identities. I think it is important, and for this reason, it's important to start from history. So know the history of construction, the history of architecture can be a good starting point also for doing innovative design. So it's not something that it's related to only to the study of historic structures, historic architecture, but this can be a good starting point for new design and innovative design processes, I think. This is particularly true for stone architecture because it has centuries of history behind us and a huge heritage that constitutes some of the best architectural examples of the past. For example, this is a volta stella, which is literally a stair vault, a typical vaulted system of the south of Puglia. And it is interesting because it is built in situ with few supports and without the using a force work. So if you look at it, it can represent an example of the best of architecture. But I think if you go, if you study it a bit better, a bit deeply, you can find something that can inspire you for the future. Anyway, the stone is an ancient material, you know, and but it has its use has evolved over the centuries until to embrace the digital revolution in the last years, and very recently also the use of robots and the use of robotic fabrication. So if you see, we will start from traditional fabrication, going to subtractive fabrication, and talking about also showing example of robotic fabrication, the use of robotic fabrication techniques, and at the end we will see also the passage through additive fabrication, which can be a sort of contradiction, but we will see it's not. The first phase of this evolution is the traditional era, which has lasted several centuries, and among all the traditional construction techniques using stone, there is one which is particularly interesting for us, which is stereotomy. Probably you already heard about it. I don't know, maybe not, but this seems a strange term. But stereotomy it's not so strange because it comes from the Greek and indicates the art of cutting solids, and it is historically related both to timber and stone, mostly stone. Stone stereotomy is well known in history of construction, history of architecture, and the term was coined for the first time by Jacques Courabel, but the history comes from the Middle Age. So the master masons, stone master masons, which built cathedrals in France, for example. Stereotomy derives from the, as I said, from the medieval cutting stone techniques, which have also been evolved to allow the optimization of the voussoirs production, the stone blocks, and the creation of more complex architectural shapes. It is particularly useful. Use the stereotomy techniques when we need to build complex geometries and when we need to control them from the early design phase. So when you build something complex in shape or complex in the building elements, it's very important to control them, control both the wall shape, the general shape, and also the geometry of the constituent parts. So stereotomy is not only a tool, it's a way for starting to imagine a new type of architecture. It can sounds a bit strange, but you will see that maybe it's true. Despite its utility from the second half of the 18th centuries, you can note the progressive fading of the art of stereotomy from the architectural practice. This year, you see here, is the year when stereotomy become descriptive geometry, thanks to Gaspard Monge. But after that year, for several reasons, stereotomy fades from the architectural scene because of several reasons. because of the introduction of artificial materials and the consequent development of construction techniques and design methodologies appropriate to their use. But I go fast. The event that changed the recent history of architectural design is certainly the digital turn, which has given the ideal conditions to overcome I think the contraposition the contraposition between modern and postmodern architects. The massive diffusion of computers for design has completely changed the reference paradigms of the discipline, I think, and we finally allowing the development of new architectural languages deriving from new design methods. Why I'm saying it? Because I think that this passage, this historical turn, the digital turn, has created the ideal conditions to renovate, to innovate, to use again the some old practice like stereotomy, because it's strictly related to architectural geometry, and most of the computational and parametric design processes are related strictly to architectural geometry, also to the optimal production of blocks of building elements. So there is a strict relationship between architectural geometry and fabrication, and that is an important aspect that stereotomy has always faced. So this is, I think, the reason because we can connect the past with the future in this discipline. The realization of this new architecture, the architecture is made from using digital tools, is allowed by digital fabrication. And starting from the 2000s, architects understood that the information of the digital 3D models could be used directly for manufacturing and construction purposes, thanks to the use of CNC machines, robotic machines, and all the tools the fabrication tools that we use nowadays. Anyway, the introduction of digital technology in the stone industry in this stereotomic field is therefore the result of a long evolutionary process rather than a real revolution. So maybe we have a digital revolution in architecture, but I'm not sure that we have a digital revolution also in stone architecture or also in stone designs and stereotomic design. Because the evolution in this field has allowed us to maintain a series of technical and practical know-how deriving from a long secular tradition, which then merged with the innovation brought by digital technology. As an architect and designer, I've started to think about how to taking advantage of these tools, the digital tools, and how to find a way to express their potentialities. In the same years, the introduction of digital technologies led to the development of the digital stereotomy, which is an update of the discipline made possible by the spread of parametric modeling tools and CAD/CAM fabrication systems. Today, in the scientific literature, the term stereotomy is used in a broader sense because it has partially lost its traditional association with stone architecture and approaching the definition of science of cutting solids without any reference to a specific material like in the past with stone and timber. This is what they call stereotomy 2.0, and in the 2018 with my former supervisor Giuseppe Falacara. I've edited an entire volume of the Nexus Network Journal about Stereotomy 2.0, which included an unfinished manifesto. And in this contribution, we stated that Stereotomy 2.0 is closely related to the use of digital design and manufacturing tools like robotic arms. We also affirmed that with Stereotomy 2.0, we should investigate the unexpressed possibilities of the discipline and overcome the limitations imposed, for example, by individual materials. Maybe we can use composite materials born from the union of materials with different characteristics. And in this sense, I've been lucky in the last years to collaborate with companies and other designers in the realization of several prototypes in different fields, such as architecture, digital crafting, and industrial design. And in the field of industrial design, for example, I've supported the company Generali, which is a Swiss stone and marble manufacturing company, in the design and realization of an experimental project, of some experimental projects, in order to show the possibilities opened by the use of thin marble reinforced with carbon fiber. The carbon fiber has been used to absorb tension stresses, so we have been able to reduce the stone, to reduce the thickness of the stone and make it thinner and lighter. The fabrication process is based on the freedom permitted by robotic fabrication and employs vacuum bonding to join carbon fiber layers to thin marble, granite or stone. And the most notable example of this research is the Lapella chair, designed by Zaha Hadid Code with the support of AKTHU, an engineering company, an engineering firm from London, and my research group, the New Fundamentals Research Group, and realized by Generali. The Lapella chair has been exhibited in New York City at the Stereotomy 2.0 exhibition. Due to the free-form shape of the chair, we carved the constituent parts from several small solid blocks. This is a picture of the Lapella's team in New York. You can see some details, pictures of the chair. You can notice the very, very thin layers of marble. Another project I worked on is the coral table that has been exhibited at Marmomag Verona in September 2019 and has been designed by Dustin White with my support and fabricated by Generali for Gruppo Tosco Marmi. We proposed a ledge format table design featuring a continuous woven minimal surface geometry to be fabricated in Palissandro marble, which is inspired us to design an organic shape of taking inspiration from phenomena like erosions of the rocks and coral reef growth patterns, so biologic and natural phenomena. And we started from a single solid block of Palissandro marble, so very, very true subtractive processes. And we cut away some parts of the block by using wire cutting. And after that phase, the robotic arm milled away the marble layer after layer. So it is a long process. Very, very long. You can see the robot in action. And after the interesting thing is that after the raw working, the raw process is made possible by robotic fabrication, the final polishing has been done by hand by highly skilled artisans. And I think it is an interesting aspect because in the stone marble field, there is always a merging of you know, nowadays there is a merging of traditional and handicraft skills and the most advanced robotic and CNC processes. I think this is a very, very interesting because at the end you have an hybrid product that can both have contains the characteristics of the robotic and the CNC processes and also the human touch, you know. So this is very, very interesting. In this case, we designed it for an exhibition that aimed to highlight the uniqueness of stone and natural materials from the, you know, the imitative materials like synthetic stone or porcelain or grass, some materials that are used in architectural projects to imitate stone, to imitate marble. And this is, in this case, we started from something that you cannot imitate because it's a huge block of marble, and the geological stratification of this block has been modeled by the organic shape. So we have a combination of history of geology with the new techniques, new design processes. So I think it's interesting. This is a quick video was given during the exhibition in Verona. We were excited to show the table because as I said, it's a perfect example of blending between robotic and artisanal skills, which is a key aspect of the evolution in stone design and fabrication that I mentioned previously. The next project that I want to show is the Flux Vault. That is a vaulted pavilion designed in collaboration with Professor Giuseppe Fallacara and the French company SNBR. The pavilion has been the representative stand of the SNBR company during Rockalia in 2017 and also in 2019. Rockalia is the French fair dedicated to natural stone, and it is held in Lyon every 2 years. Flux is I don't know, say if we define it vaulted structure. Maybe it's a blending of 4 arches, maybe, but covers an area of 36 square meters and has a maximum height of about 3 meters and 20 centimeters. The shape of the structure derives from a base structure formed by a network of catenary curves in such a way to make the vault subjected almost only to compressive stresses. That is a key aspect when you design something that is built in stone, because, you know, stone, it has a very high resistance to compression stresses, but very low resistance to tensile and stresses. So it's important to control the shape of the structure. It's important to control the thickness, because we need that the forces and the stresses all around the structure not affect the equilibrium of the structure itself. It is very important. So that's why we use we base the design shape on catenary structures, because with catenary structures with catenary curves, sorry, using catenary curves we can control better the equilibrium of the overall shape, the equilibrium of the block. But another very important aspect in this case was to the speed of construction of the vault of the structures, because we had only 1 day to build it. So and another there are other 2 important aspects to face with this project. One was it was not possible to use a false work, so we used a structure you will see that was made from supports that not using a true false work. And another aspect was to design the blocks in order to lift them using very limited instruments. Each block has been designed to weigh less than 500 kilograms, which is not too much using stone, to facilitate assembly and to be produced by using robotic fabrication tools. And another important aspect of the project is that each contact phase among the various voussoirs presents metal fixing systems. It has bolted fastening system placed on here on the plates and at the outer edge of each block. And due to the complexity of the stone blocks to be produced, robotic fabrication is the most appropriate technique to use, because we use wire cutting to cut the contact phase between blocks which are completely flat, and we used also milling for carving the overall shape of the blocks and their sculptural aspects. You can see here that is a relevant factor in this project. Maybe there is a video here or not. No. Okay. I thought that was a video. Not sure. Okay, yes. The precision allowed by robotic fabrication is a key aspect of this project, also for its construction, because the details we design have been permitted us to disassemble the structure in just 2 working days without producing wastes in scaffolding. In fact, each voussoir was lifted from the above and temporarily attached to a metal frame structure placed above the vault, and each stone block was positioned and mechanically fixed to the subsequent ones until the keystone was placed in position. This is a new construction technique in stereotomy. We experimented with this prototype for the first time, and it has been relieved very efficient, very I think also it has improved the mechanical behavior of the structure, because this kind of metal plates, metal fixing system has made the structure to be more elastic, which is it's a bit strange of related a bit strange concept related to stereotomy structures or masonry structure, because it has to be very, very rigid. In this case, we combined the rigidity of the stone, but also the possible of micro movements between blocks, you know. And it was very, very great experience. And also because the fabricators, the SMBR company, was very, very skilled in also both in robotic fabrication, you know, very, very precise, very, very perfect, I can say, and the fabrication experts. Also, they are very, very good in assembly, which is very, very important, because if you have perfect blocks, but you're not able to assemble them together, you surely will not get the ideal result, you know. So it is very, very important in architectural construction, this kind of aspect. The sculptural relief of the intrados remembers the flow of internal forces of the structure. So this kind of, it's like a representation of the structural behavior of the pavilion, and they proceed from the arch to the ground seamlessly. On the other hand, their presence, so the presence of the sculptural relief, intends to enhance the technical capacity of the latest generation of CNC machines. And on the other hand, they represent a possible way to revamp the sculptural tradition that has always characterized stone architecture in a contemporary way. There are some pictures of the finished pavilion and some the details pictures. You can notice the very high precision of the robotic manufacturing and the details of the metallic connection between blocks. These are other pictures took during the Rocalian fair in Lyon. You can see also the interaction, which is the tactile exploration from the audience, which is another very interesting aspect when you use also digital technology, because maybe we can think that something that has been produced with digital technology is perfect, but it's not true, because if you can see here that it's possible to notice the milling layers, the milling path that the robotic tools leave on the stone surface, and it's interesting to maybe to explore them by touching it. So I think this is a fascinating aspect to highlight. In the initial project, we designed also a cap to be made by micro concrete or 3D printing. But however, for budget and time reasons, the top of the world has not been realized yet. I think it will never be realized, really. But I'd like to show because maybe we have a bit of contrast between the two parts, but I think also contrasts are interesting in architecture sometimes. Another option will be to continue to build the cap by following the contour lines of the structure, as you can see in this picture. And I think this is a good option to also optimize the construction of this kind of pavilion, because in this way we can install firstly the arts, and after that we can continue layer by layer to place blocks until the structure is end. Always using very limited and reversible supporting structure. Supporting structure, and not using a false work, which is always a problem, because it's like you have to build two structures, the support structures that at the end you have to waste, and the structure itself. So I think in order to make this kind of structures and architecture more sustainable in terms of budget, in terms also of environmental aspects, maybe make some efforts to avoid the construction of waste materials, waste force work is better, I think. Other pictures have been taken during the Festival Européen de la Pierre 2 years ago, or maybe 3 years ago, at Château de Rouen in Saverne, which is a very good location for this kind of project, because we have in an historic context. And the same vault has been, they made it made probably more trips than me in the last years, and has been built again at the Venice Biennale. The pavilion is currently exhibited there, and exhibition in the installation curated by Professor Giuseppe Fallacara, called Porzione di Infinito, namely portion of infinity. So if you are in Venice, if you go in Venice, you can see it, and maybe you can send me some pictures. But if subtractive techniques seems just the digital update of the handcrafted techniques used by centuries for the classic stereotomy, additive manufacturing techniques are opening new scenarios for the discipline. I go fast. Projects developed with subtractive techniques are characterized by a series of critical issues. Maybe you noticed some of them during my presentation, because we have to deal with limitation in the fabrication of complex shapes, waste of material, and its appropriate disposal. We have a... okay, thank you. Waste of material and its appropriate disposal, and also recycling of processing water. Many of these limitations could be overcome with the transition to additive manufacturing techniques, I think. And today, further methods and tools for additive manufacturing has been developed, characterized by the use of different materials and different manufacturing processes, to which corresponds a degree of precision appropriate to the scope of its application. In the field of construction, in my opinion, the most suitable additive manufacturing techniques are material extrusion and binder jetting. We will see some examples now. The different approach to additive manufacturing can be classified into 4 categories. Extrusion of wet compounds for the manufacturing of monolithic buildings, extrusion of wet compounds for the manufacturing of discrete elements, solidification by layers of powders for the manufacturing of, again, monolithic buildings, and also in contrast for the manufacturing of discrete elements. Now, additive fabrication of monolithic buildings aims to bring down costs and construction time, realizing ever bigger 3D printers. This is, I see this is an idea that is currently on the stage. However, this objective poses, in my opinion, several critical points because the dimensions of the building are constrained to the size of the printer. Obviously, the structure must be necessarily monolithic, and the construction is also monomaterial. So I think that there are weaknesses of this kind of monolithic additive fabrication processes. In contrast, we can use also discrete additive fabrication, which has a lot of potentialities, because open up the possibility of working extensively with non-standard products conceived and created concerning a specific project. So in terms of mass customization, they are very good. And with the use of materials that are more appropriate to the nature of the project, or also an important aspect, they are local available. The construction of blocks obtained by additive manufacturing of stone-derived compounds can represent also a natural evolution of the construction processes of the stereoatomic architecture, which is the topic of my lecture. And this is also a recent great example on how it's possible to do 3D printed architecture made of blocks, you know, very big blocks and very different in shapes. So they are all different, and they follow the geometry, the architectural geometry of this bridge. It's a project designed by Block Research Group and the Zaadid Code Group in collaboration with Allchim and Incremental 3D. And I inserted this project because it's recent, very recent, and also because it's a very interesting design. And but the most relevant aspect that I want to highlight is the use of material extrusion technique combined with advanced computational design strategies. So maybe you can search for more info if you don't know this project. And the interesting part, the interesting aspect is that they do this block using a simple robot that extrude layers of cementitious compounds. So I think that is very interesting because they also studied a process in which you can design and fabricate curved blocks. It's very interesting in order to make this kind of architectural shapes. Within these scenarios, we have developed some ideas on which we are basing our future research. The first project is additive stereotomy, which is a research project we have developed in collaboration with Diederik Veenendaal from CMM Engineering. Additive stereotomy represents a novel building system thought to realize a vaulted space So I received a message from Angelo. I'm not sure he will join the lecture. So maybe I can talk also about the part, the environmental part of the lecture. Was saying this additive stereotomy represents a novel building system to realize a voltage space to be fabricated using large-scale additive manufacturing techniques. And material properties are based on the 3D printing technology provided by Concrete, which is a Dutch company who builds large-scale inkjet 3D printers that uses a patented inorganic polymer material system to create custom, highly precise stone parts. So you can make block by using sandstone, for example. The main idea that we had was to design a big open space, which is not so common in stereotomic architecture, covered by a series of adjacent arches. So we have not a true vault system, but we have a shape made of stereotomic arches. And these arches under permanent load are thought to be statically independent to form a sort of false vault. I know it can sound a bit strange, but the use of side-by-side arches allows the creation of free-form barrel vaults in which the overall shape of the structure is not conditioned, is not constrained by the static functioning of a traditional vaulted system. Because, you know, traditional vaulted system have to follow a precise shape because we need that they stand and they not collapse under the load. And sometimes it's not always possible. It's impossible to have, for example, anti-clastic shapes. But maybe we are interested to explore this kind of shapes for architectural reasons. So static structural behavior is not the only relevant aspect in architecture. Maybe we aim to explore other kind of aspect, other kind of shapes, other kind of forms. So we developed this kind of system, the tectonic system we can define in order to use some kind of stereotomic ideas, but in a new way. In other words, each arch must resist only its weight and the pre-stress loads. These arches are divided into voussoirs, so the stereotomic aspects are more related to the architectural geometry of each block. And these voussoirs have a load-bearing core, this one, and the two variable cantilever slimmer parts on the sides. The variety of these cantilever parts make the variability of the openings, which is another difference from the classical stereotomic shapes, because they are completely closed usually because we need to create the structural equilibrium by friction between all the blocks. In this case, we have independent arches, so we can because they are independent, we can create some openings between them, and the structure stands. The cantilevering side part can be shaped in such a way to create differentiated openings to permit natural lighting and at the same to come in. At the same time, we can imagine to insert artificial lighting systems integrated into the structure. And the project was developed internally in Grasshopper to create a close synergy between parametric design and computational engineering. Another idea we explored was to make these blocks optimized topologically optimized. We have worked with Simone Rutigliano, former graduate student in architectural engineering, on topology optimization of the voussoirs in order to achieve constant stress by using materials only where it is needed. The entire arch is pre-stressed by tendons to deal with live loads and allowing the assembly and disassembly of the arch. And some engineering with Diederik Dennendahl determine the shape of the arch and the volume fraction of the voussoirs to achieve constant stress, as well as the amount of the press stress to keep them in compression under external loads. You can see these percentage are related to the volume fraction or inside the blocks. So the idea is that the shape of the blocks outside is completely full. It's like we have here, you can see the shape completely full, but inside the volume of the blocks change every time depending on the position of the block itself and depending also the amount of loads to be faced by the block. So and in the lower part we have blocks that are almost completely full or full. And in the middle of the arch, we have blocks that can resist to less stresses, so we can have volume. Maybe they are emptier. I have to explain it to make it understandable. It's not so easy to explain for me in English, so I hope to have been clear. But the first design application. Sorry?
I totally feel your pain about explaining something in English that is not your mother language.
Yeah, it's not my mother language, but also they are a bit complex to explain also in Italian. So the complex, the idea is not so easy to explain. But thank you. The first design application of the construction system is represented, has been presented in the exhibition Cerotomy 2.0 that has been held in 2018. Okay, thank you, Rebecca. 2018 at the New York Institute of Technology. The project you will see is some kind of a robotic reproposal of the project of the famous National Library designed by Boulez. In our project, we have placed servers and supercomputers along with the basement instead of books as a contemporary analogs for the preservation of human knowledge. We had this idea to represent the project. I think that we can use artificial intelligence, robots, computers to shape the world we live in. But everything we do, every action we do, we have to make a reflection on what we can do and why we do that, because we have the responsibility of our action, and the future is totally up to us. So maybe there is something philosophical also in this image, because we imagine like an architecture for robots, for humanoids, you know, instead of an architecture for people. And maybe in the future we will, with the explosion of artificial intelligence, the robotic, maybe we will start to imagine architecture not for human but for robots, for humanoids maybe. And it will be also interesting to understand how to do them, and it was just a first step in this reflection. The last project that I want to show is Urban Dunes, which has been designed by me with Michaela Colella, which is my partner at Barbera Colella Architetti, and with the aid of Angelo Figliola on environmental design and environmental analysis. And it is the second project we designed using additives, this additive stereotomy framework. And in this case, we had a location, we had a specific site, a specific project schedule, specific project goals, because the project has been developed as an entry at the Cool Abu Dhabi Challenge, which was an international call for designing a new model of covered urban space in Abu Dhabi in order to face the problem of the urban heat island. So in this case, stereotomy has been used as a framework to face a climatic issue. Due to the urban heat island effect, the city center of Abu Dhabi is estimated to be several degrees Celsius warmer than surrounding natural environment. You can see here the difference. It's the temperature of the soil is almost the double of the surrounding environment. And solar absorption and re-radiation from the surrounding context, as well as the anthropogenic heat released by cooling the building, and the lack of air movement result in a felt temperature being much higher than the prevalent air temperature. So we have also, when we stay here in this kind of in these countries, you know, it's very hot, that are very hot and desert climate, we perceive a temperature that is higher than the real. So this is a problem, because people don't use urban spaces for this reason. They move from a building to another building. They move by car, but they don't leave the city outside. So this for this reason, we need to design something that is appropriate to face this problem. And our design process started from the deep awareness of the climatic context of the Abu Dhabi's and Emirates traditional architecture, which is composed by elegant vaulted structures, vernacular shading devices, cold water basins, a lot of very, very interesting and cool elements from the past. If you see Islamic architectures, very, very interesting. The fact is that they don't want to use them anymore. They prefer to do something that is that comes from Western civilization, you know. I think that is I don't know if it's stupid, but I'm not agree. I don't agree, because they have a very, very special, a very, very interesting heritage, architectural heritage that can probably reuse or probably evolve. A message in the chat.
Yeah, that's me. I'm saying I
Okay.
don't either. And I think that it's a trend in all like big civilizations to leave aside their heritage and just turn into either Western or contemporary architecture at some point and leave aside all the parts that they built in centuries.
Mhm. Yeah. Yeah, the problem is the memory, you know, because and also maybe because it's not so easy to understand architecture of the past. It's not so easy to it's not easy to extract some interesting part that can be evolved in a new way. You know, you have to do you have to make some efforts, and also when you have a good design result, you have to communicate them. You have to convince your clients to follow you. So it's not a very easy process, because if you see that the common paths that are followed by for the creation of a building, sometimes most of the time you have you receive as an architect a specific client request, and it's not always possible to reshape that request in order to make something that maybe recall the past, you know. So it's not an easy process. In this case, we worked on this framework, but our idea was to design vault composed by 3D printed blocks, because we wanted to use the desert sand, because you know, in a desert climate, in a desert area, you have only sand. Yeah, and so our idea was to say, okay, we have desert sand. Desert sand can be used, obviously it needs to be processed, but desert sand can, maybe we can imagine an architecture made of desert sand, and this desert sand can be processed using binder jetting 3D printing fabrication process, and at the end we can maybe obtain solid blocks, a sort of 3D printed sandstone. And this sandstone can be used as a material for build a vault structure. And this was our idea. It's also very interesting because can you hear the music? No, okay. So yeah, it's not important. If you go to the EXO-1 YouTube channel, you can maybe see this video is a bit long, but it's interesting because they explain how it's possible to set up a factory made of 3D printers that can work together and can also make a big factory of 3D printers that can produce a lot of this kind of blocks, for example, to use in the construction field. And again, concrete that I mentioned previously for the additive ceratomy project has developed this big printer, 3D printer that can produce very big blocks. They are specialized in the production of 3D printed blocks for architectural purposes. Okay, because most of the other 3D printer producers maybe use them for rapid prototyping or for make stamps for no stamps for make something that is not appropriate for the use of in construction, but they are focused on the use of the production of blocks for architecture, which is important for us. Sorry, you know. Okay, sorry. And the main architecture idea behind the project is to easily lift up a thick layer of sand in order to create an urban oasis, which mixes passive and low-tech active systems to maximize the outdoor thermal comfort calculated with the UTCI index. The use of a 3D printed vault made of thickness of 45 centimeters permits to avoid the overheating of the urban space under the vault, thanks to the high thermal mass of the shell, acting as a main passive strategy. So first, when you have a very, very hot climate, the first action you can take is to protect the inside of the building, inside of the urban covered space, by using very, very massive materials. So stone, sandstone, you know, that are very, very appropriate for this use. And the sand is mixed with a heat reflective cool pigments to increase the surface reflectance and to reduce surface heat build up. That's reducing also energy consumption through lower cooling requirements. The space below the vaults represent an urban microclimatic space protected from the sun arriving using a vernacular sun shading device, the Musharabia, which enhance also the natural ventilation of the space. So the ventilation can pass through the Musharabia, but the sun a bit less. And the wind meets the perforated surface of the Musharabia and it increases its speed to the Venturi effect. This incoming airflow meets and touch the cold water basin here, all around the space, spreading a sense of freshness inside the building space. In addition, the urban under the shell is also naturally ventilated with the use of low-tech system as the hard pipes. We have a mini wind catch tower here. They can collect the prevalent ventilation, the prevalent winds, and the air can pass through this earth pipe, and they are fresh because they are inside the ground. And it is a low-tech system that can fresh the air naturally, and we can, after the wind has been made fresh by this process, we can use to refresh the inside of the vault. That's why we have this kind of openings here, because the openings that seems like a decorative part in reality are being made to both put inside fresh air. Also, we have integrated high pressure misting misting system to reduce the temperature inside the vaulted space by forcing water via a high pressure pump producing a microfine mist. So we use several bioclimatic devices or low-tech devices in order to make the inside fresher. I thank Angelo Figliola, who performed the environmental analysis, who certified that the mixing of those systems, it is possible to reach the UTCI of 26 degrees Celsius for the month of August. That is the warmest month in Abu Dhabi. And that represents a real comfortable thermal perception for an outdoor space. This is a short video we prepared for the competition. We didn't won the first prize. We'd only been awarded with an honorary mention, but it was a great recognition, I think, because we know it was a very experimental project, but also to be awarded with an honorary mention was great. I'm sorry, you can hear the music. There is an Arabic soundtrack. So we recently had we did a workshop in online workshop on data-driven additive morphologies, but what's going on? Okay. We had also a lecture from Nick Bao. In this workshop, we tried to also implement other kind of preliminary analysis, like also structural analysis and environmental analysis, in order to optimize the workflow, optimize the design process in the early stage of design. But maybe I will not talk about it because oh yeah, not too much, but an interesting part was to use Kangaroo in order to make optimized shells under compression stresses. You know, the reproportion, restudy of the shape of the pavilion of the Venice Biennale using by this kind of workflow. We also developed a a workflow using sub-D modeling integrated to Kangaroo optimization. Yeah, we developed a workflow in which we started from a coarse mesh, which is a mesh constituted by very few faces, using a sub-D modeling conversion. It's like you know, if you use Maya, you know it very well. It's a way to use NURB surfaces in combination with the mesh, coarse mesh that controls the shape of the 3D. This shape has been used as a basis for the form finding optimization of the shell. Also, we use it for the tessellation of the shell, and this tessellation was analyzed both in environmental aspects and also structural aspects in order to extract data and inform the, for example, one of the morphological morphological aspect of this of the shell was, which was for example an old structure in which you can permit lighting to pass through, and this opening I don't know to say, opening percentage opening ratio was informed by radiation aspects, climatic analysis aspects. So this is a topic we are working on in order to make more informed stereoatomic structures. This is a direction we want to. So we want to integrate fabrication aspects, morphological aspects, technological aspects, and also environmental aspects in a seamless workflow. This is our new direction. And the next steps, the next step is to use all of this kind of workflow to make something that is not simple as shell, you know, but we aim to design an architecture, so with functions, with the program layout. Maybe the most simple example is to design a complex or maybe not so complex roof which covers maybe an area, maybe a building. Inside this building, the interesting part would be to deal with all of the complexity of a real architecture. This is our purpose for the future. And finished. This is the book. It's all for the moment. It's in Italian architecture. So if you want to learn Italian, to study Italian, you can you can buy it. In which it contains our project or experimentations, and also our theoretical reflections. And this is also the book that Angelo did, Post-Industrial Robotics, which is very interesting for the topic of robotic fabrication. So thank you very much. If you have any questions, I'm here to try to answer them. Thank you very
Mauricio,
much.
Thank you so much for this lecture, and I think that you have a great ability to present so complicated topics in a very kind of clear and simple way that is understandable for second-year students that is your cohort today, and thank you very much for doing it. So many questions emerged from this presentation, and I think that we need more of 2 hours. Before I ask you the first question, probably I want to ask the other members of the panel, the students, if they do have a question, now is your time to ask, because I know that several of you're working in similar topics, and I think that Mauricio today clarified a lot the things that we were discussing during the tutorial. If Nicholas, Christina, Sina, Dalia have a question, Rebecca, Darcy, whoever is in panel.
I have a question. Yeah, thank you so much for the presentation. It was awesome. With that pavilion arc that you had, I had 2 questions about that. Actually 3. What did you use to connect those metal panels to join those segments together first? And also, when you said the waste was properly disposable, what do you mean by that? Is it like recyclable, or can you use the waste in other part of the projects? And also with that pavilion curve, did you have you done any vibration test to study how they react, because it's a heavy structure, and if an earthquake happening, how they react and how they behave through those joints. That's it. That's all. Thank you.
Can you hear me?
Yes.
Okay. I don't know, maybe camera problems. Okay, I'm in. So the first question was about the metal system.
Yeah. How you fix that to the actual stone, and what did you use to fix it?
Oh,
to the
yeah,
stone?
yeah. Oh, yeah.
Was it like an epoxy?
Yeah, we
or
fixed
it
it by. No, it the block was carved in 2 points.
Mm-hmm.
Yeah, in the contact phase, you know, we carved it in 2 points, because what you've seen is the metal plate, but the metal plates have 2 bars inside the stone.
Yeah,
so we use the epoxy resin to join them in order to make them like one thing. This is the first question. And but the vault is not reinforced. It's not a reinforcement system. It's just a system to connect the metal plates to the stone in a more stronger way, you know. The second question was about the wasting material.
The disposable waste, and how is it recyclable, or is it just what do you mean by properly disposable?
The problem is when you see subtractive processes you install in a more evident way, you produce by using water to reduce the heat of the instruments, of the cutting tools. You produce also the water collect also the stone powders, you know. And you need to treat them to the water and to separate the. But actually, there is no an evidence of approach on reuse this kind of disposal material, which is a problem because thinking about circular economy, it will more interesting, more intelligent to try to reuse that raw material, for example, for 3D printing, you know, you have to process. Okay, but we have the same problem in the timber industry probably.
Yeah.
Because I was I was talking with my friend which is a how to say furniture fabricator, and he's saying me that they have a lot of waste in wood panels, on plywood panels, and actually the problem is that it is forced to pay to dispose these waste materials. Maybe in thinking about circular economy, thinking about sustainability, we can start to imagine to use them, to process them, to use the, for example, in 3D printing, or for example, in other kind of additive processes. So this is a problem, and this is I think a big problem in stone industry. And the third question was about.
Have you studied any vibration behavior for that pavilion arc between those joints? Like, because it's like a very heavy structure, and if it vibrates, it might collapse because of its weight. Have you done any study on how rigid or how resilient are those joints through vibration?
Really, yeah, this is a good question. Not yet, not yet.
Okay.
It could be also interesting to study the vibration behavior under, for example, when you simulate an earthquake. You know that if you put it on an earthquake plate, vibration plate, it could be interesting to understand if maybe it maybe performs better than a masonry structure. You know, masonry structures has always had problem with earthquakes because it's a rigid assembly. Now, you have rigid blocks, you have very fragile material, but maybe using this kind of elastic connections, maybe we can perform better. Also in probably yes, but I'm not sure.
All right, cool.
Thanks,
man. Thanks.
Thank you.
Please.
Does anybody else have something to ask Maurizio? Then I will start asking because I think that Sina started a very good and interesting conversation how this research can go further, but also he pointed on conditions that probably this approach might be way better than a monolithic approach of a concrete structure or a 3D printed monolithic approach, because if we see in history examples, all these structures that they were component-based structures lasted in time, and they can absorb all the vibrations of earthquakes and probably all the other aspects that are happening. My questions are more about fabrication and the clarity of your process. I would like first to ask, since you have a very methodological and strategical approach from concept to delivery, when do you start to think about fabrication? What is the point within your process that you say, okay, I'm thinking of a form and I'm translated into some kind of structure that can be fabricated very early in your design process or in a mid-term?
Yeah, it depends. It depends because maybe there are projects in which you try to design something that is already optimized in a fabrication aspects. So in that case, you start by thinking on this topic first. But in the examples I show, for example, in the flux vault, maybe the subdivision of the blocks, it was not the first aspect we analyzed. But in that case, that topic it was under control, because at the end we have just 4 hours, you know. Maybe in the Urban Dunes project, we started by thinking that our aim was to design something that we can build by using 3D printing. So in that case, we used semi, what to say, it was a modular structures, if you see, but a lot of elements are are not mass produced, are mass customized. So in that case, we started think about the shape first, but also having in mind that our aim was to use and to enhance the use of to represent the use of 3D printing possibilities for stereoatomic structures. So surely it's not something that you can start thinking at the end. But depending on the project, you can start at very early stage, or maybe a bit later, but not so much later, because if you think only about the shape and not about the fabrication processes, the problem is that at the end you can not control the fabrication processes, which is not a very good idea, I think.
Correct. So you have to think like you have to have that in mind. And my second and last question, and I won't start you with that minor things that I want to ask. But when you say about fabrication, and you mentioned and you analyze a lot in the Flux Pavilion, in the Flux Vault, like the help that you had from the company in terms of the assemblage. So when you are assembling something and you're collaborating with an external industry partner, do you discuss assemblage with them, or you take this into your process of fabrication, how this will be assembled, and you have to come up with a strategy that says the assemblage is, this is my strategy to assemble it, and you have to follow my guide?
The problem is that when you start a collaboration with an industry partner, for example, I think that my suggestion is to understand how they work, because if you know your partner, you know, you also you can learn from them. You can understand how they work, because probably if you come from an academic context, maybe I'm not sure you're aware of the industry works, you know. So my suggestion is to try to learn also, but in the same time, I think that my suggestion is also to try to always introduce a bit of innovation, of a bit of something different from the way they work, because in this way you can start a discussion with you start dialogue with the industry partner. So it is very important to establish a relationship with the industry. It's not something you can do imposing something. You say you have to do it, and we stop the discussion. I think it's much. It's better. It's more interesting to understand and to try to say something more than usually. So I think it should be a win-win process, you know.
Yes, I understand totally what you're saying. That's it for me. If somebody else has to ask something in the conversation.
I have one more question. Sorry. With that tunnel that had curves, was containing from curves, how do you in your design, how do you connect those curves together? And is there like a control joint in between each curve, or they just tied together, like sitting really tight? And what's the fastening? How do you prevent from like all the curves to fall off?
I'm not sure to have understood the question. You mean when we
you have
when
so
we lifted
many
the blocks?
curves. You have so many curves that's sitting beside each other. How do you connect and fix these curves together? And is there a control joint in between each curve, or are they tied together sitting?
No, in the structure we designed, we how to say, we maintained a degree of freedom between rock, because it was the first time we were not sure that the assembly will be perfect, you know. So we not design how to say, a pact of something that you force the assembly in that sense. But maybe thinking about an evolution of this kind of connections, because we are working with CNC machines, you know, you can be very, very precise. So the precision is not a problem. The problem is that when you are moving something that is very, very heavy, the problem is to manage it, you know. So you have to preserve a certain
there are variables
grade
that you're not
freedom.
Yeah.
The problem is not the precision, because you can design something that can perfectly stay in position, but the problem is that if it's too precise, maybe you can face problems during the assembly. So I think
okay, thanks.
Well, on that note, if there is no more question, I would like to thank Mauricio for being with us so early in the morning in Italian time, and sacrifice his sleep for showing us all the magnificent work. Thank you so much for coming, and I know that you gave us so much inspiration today and ideas to think about. Looking forward to see if some students will catch up on these ideas and take them further. And on that note, I would like to thank you and thank all the panelists, for all the people in the panel that stayed like until now. And I'll see you all on Tuesday.
Great. Thank you so much, Maurizio.
Thank you, Maurizio.
Thank you very much.
Maybe now is the time that you all unmute yourself and start saying bye, 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 bye.
Thank you. Bye.
Thank you very much for inviting me. Bye bye, guys.
Ciao, Mauricio.
Ciao, ciao. Thank you.